All right, let's keep on going. So the next in the list of things to prove is the fact that tangent of any number plus cotangent of that number is always equal to secant of that number times the cosecant of that number. So let's try to do it. So you came up with the proof that you came up with. I'll do one too. So maybe I'll try to manipulate the whole equation. Whether multiplication is more complicated than addition is, well, maybe an open question. So let's see. Let's write down the equation we want to prove. We want to prove tangent of z plus cotangent of z is equal to secant of z plus cosecant times cosecant of z. And, well, it's upsetting that there are so many different trig functions floating around here. In order to simplify, let's express everything in terms of sines and cosines. Rewriting in terms of sine and cosine, we get sine over cosine plus cosine over sine is equal to 1 over cosine times 1 over sine. Alright, so it looks like I see 3 different fractions in play. Well, you might say 4, but really just 3. There's one, there's another, and 2 fractions multiplied together is easily another fraction. That's the same as 1 over cosine times sine. So let's get everything to have a common denominator. It looks like that common denominator will be cosine times sine. Let's get a common denominator. And what will that give us? Well, let's see. This first piece we want to multiply and divide by sine of z. So we'll get sine squared z divided by sine z cosine z plus this one we'll need to multiply by cosine divided by cosine plus cosine squared z divided by cosine z sine z equals 1 over cosine z sine z. So how do you multiply fractions? You just multiply the numerators and you multiply the denominators. It's easy to multiply fractions. It's adding fractions that's hard. But now that we have a common denominator, it's not hard to multiply fractions. You just add the numerators. Adding fractions, we see that we get sine squared z plus cosine squared z all over sine z cosine z equals 1 over cosine z sine z. So you see the numerator on the left-hand side. The numerator is sine squared plus cosine squared. That's exactly 1 by the Pythagorean identity. By the Pythagorean identity, we get 1 over sine z cosine z equals 1 over cosine z sine z, which is a truism. A truism is an equation which is obviously true. That is a truism because it's just a thing is equal to that same thing. It's true because equality is reflexive. So since we have reduced tangent z plus cotangent z equals secant z cosecant z to a true equality, tangent z plus cotangent z equals secant z cosecant z is an identity. And it's nice to include those concluding sentences. It's nice to tell the reader what it is that you've just accomplished. Cool. So let's keep on going. Let's verify the identity. Sine squared phi divided by 1 plus cosine phi is equal to 1 minus cosine phi. And maybe, you know what, we haven't done this yet. It's nice to see if you even believe these things. So let's go off to the side and see if we can believe this type of claim. And you don't need to see me type, but I'll go ahead and plot both sides of this equation. All right, so we're back. And here, I just graphed these two curves. Sine squared divided by 1 plus cosine is in red. You don't see it at all. Divided by 1 minus cosine. So, if we plotted it using a machine, it looks like the red curve and the blue curve are in literally the same place. So yeah, these two functions should certainly do, according to this graph, appear to be exactly the same. So I think I believe this identity. So let's try to prove it. So maybe I'll follow the same strategy. I'll start with the whole equation and I'll manipulate it. So we want to prove sine squared phi divided by 1 plus cosine phi is equal to 1 minus cosine phi. Well, I see a fraction on the left-hand side, so let's clear that denominator. Clearing the denominator, we get sine squared phi is equal to 1 plus cosine phi divided by 1 minus cosine phi. Distributing, because on the left-hand side I see two complicated things multiplied together. And how do you multiply together sums of things? Well, you need to use the distributive law. Well, I guess another way of saying that is I am FOILing out the left-hand side. I get sine squared of phi equals 1 minus cosine squared of phi. Ah, wait. Which is true by the Pythagorean identity. Thus, sine squared of phi divided by 1 plus cosine phi equals 1 minus cosine phi is an identity. Cool. Last one. Let's prove tangent plus cotangent divided by secant times cosecant is equal to 1. And as a hint, if you can reduce an identity to another identity that you know and have proven, then that completes the proof of this identity. So let's try to reduce this identity to another one that we've proven. So let's review the things that we've done. So let's see, there's this one, but that doesn't involve tangent or cotangent, or secant or cosecant for that matter. Here's one. This one is an equation that involves tangents, cotangents, secants, and cosecants, so maybe it'll be useful. So let's try to reduce this equation to that one. And I kind of see an obvious thing to do. Let's clear the denominator. So let's see, we want to show tangent of alpha plus cotangent of alpha divided by secant alpha cosecant alpha is identically equal to 1. Well, clearing the denominator, we get tangent alpha plus cotangent alpha is equal to secant alpha cosecant alpha. Oh, but that's exactly what item 8 says, which is true by 8. So we don't even have to proceed any further. We've reduced the equality that we wanted to show to an equality that we already know is true, so we know that that equality must be true. Thus, tangent alpha plus cotangent alpha divided by secant alpha cosecant alpha equals 1 is an identity. Cool. So we'll go ahead and stop there. Take a look at the homework associated with this lecture. It's going to have you prove a bunch of more trig identities. I'll have you submit those. All of your written work, I want to read your proofs. So I'll look forward to seeing those. Ask me any questions. Talk to you later.